Okay, today we're going to start 4.8, analyzing graphs of polynomial functions. It'll seem like some of this is a review, and it's a repeat. We kind of just keep adding little bits and pieces, which is kind of a nice route to go on this. But to begin with, so we can start today's stuff, I want you to go ahead and work on page 111 of your student journal. The exploration there, you can work together. Do your best, take a couple minutes and do that there. Okay, so let's make sure, because we've done a lot of these, sometimes we just don't read as carefully as we should. Okay, match each polynomial function with its graph, which is what most of you will do. Explain your reasoning. Some of you may have done that. Then, use a graphing calculator to approximate the coordinates of the turning points of the function. Turning point would mean like this little bump right here and that little bump right there. Okay, how many did that? All right, so we're not quite done. Keep going. Okay, thank you. So, the first graph here. Graph goes with which function? Goes with function C, okay? And how many of you used y-intercepts to figure that out? It's really quick if you use the y-intercept, right? Especially when all the y-intercepts are different. It's always your constant and back. It's easy to match your graphs, okay? So, if I were to say those are my graphs, okay, which I'm saying, those are my graphs, all right? Matching up the functions. Graph A goes with function C, graph B goes with function E, graph C goes with function A, graph D goes with function D, graph E goes with function F, and graph F goes with function B. Okay, so if I kind of zoom in on those now, the next piece is to calculate our turning points. Okay, now if I were to graph one of those, say like graphing the first function, how many of you are able to find turning points? Okay, how many of you think you might have been able to find them, but you're not sure if they're the right points? Okay, did anyone use the trace feature? Okay, I'm going to go ahead and put this function in real quick. You got x cubed minus 2x squared. Whoops. Let's fix that. All right. So I've graphed it. I'm obviously not in the correct zoom, so I'm going to go zoom, standard, zoom 6. Let's see. You should get the function. There it is. All right. So if you use trace, this button right here, you can actually, you get a little cursor, little spider-looking thing that cruises up and down your graph as you push your arrow keys. And you can kind of estimate. You can say, well, that top point right there looks like, notice when I'm versus going upward and then going downward, that's really what I'm trying to find there. If I just watch my y values, they're increasing. Okay, so they went from 0.21 to 0.56 to 0.98, it's still increasing. To 1.1, still increasing. To 1, okay, 1.1 to 1 started decreasing. So it looks like it turns at about 1.1. All right? So if I think of that, I could say, well, my turning point, if I'm trying to find my turning point, maybe I say my turning point is like at 1.1 on y and negative 0.2-ish on x. Anyone else get that? Okay. And so the one thing, I'm going to double check my function just because I typed it in really quick. I got some other functions in there, so I want those. But x cubed minus 2x squared minus x plus 1. Okay. So the other way to actually do that, this point right here in some of your vocab today, this is called a relative maximum. It's not called the maximum because there could be multiple maximums. In this case, this graph only has one maximum point, and it's right here. This is called a relative minimum. Okay? So when we're looking at this graph, this point up here, relative maximum, relative minimum, I could use the calculate feature. So if I go to second trace, there's a button that says, or there's an option that says max and min. If I want to calculate the maximum, I hit number 4, and then it says left bound. That means as I'm going up, when is my graph to the left of the maximum? Well, right now it is, so I can hit enter. And then I got to move until my graph passes that little turning point right there. Okay, right there it did. So I go left bound, and now I've got right bound, and this says guess, so bring your cursor as close to where you think it is. Notice it's kind of narrowed the domain there. Okay, and then we hit enter. So my actual turning point is negative 0.21 and 1.1. That's pretty close to what we had, right? Okay, but it gives you the actual turning point. Okay, so negative 0.21 and 1.1. 1 if we, okay, or negative 0.22, I guess, if we round it, and 1.11. Okay, questions there? All right, so I want everyone to calculate the minimum now using that function. Did anyone do that before? Good. All right, well, go ahead and calculate the minimum now using that same operation. Calculating a minimum. Left. Okay, that was 1.55 and negative 1.63. Good? All right. Very good. Okay, so those are relative maximum minimums, also our turning points. Okay, so we're going to add that into our graphs now. Okay, so now we have our x-intercepts, our y-intercepts, which we know how to calculate, and our max and mins, relative max and mins that we're going to add in there. Okay, now when you get to calculus, you're going to use derivatives to actually calculate that point by hand. We're not doing that this year. Okay, it'll be fun though. You'll love derivatives. Remember this. If you've never heard of derivatives, and this was the first time, you just remembered this was the first time you heard of it. Yes, yes. 9:56 on December 8th, 2015. All right.
I remember
9:57.
talking about derivatives and looking them up online.
Hey, those of you that you guys, if you want to see how to do that, I've actually put it on the website too. But there you got it. Those are the actual turning points of the graphs. Notice some of them, like graph E for this, or excuse me, graph B, function E. I'm done talking, please. Notice it has a couple turning points. So it has a minimum, a maximum, and it has another minimum. So you have to calculate two different minimums. All right. So on that one, for equation E, you have a couple different points here you need to work on. All right. Okay. Now, with that being said, I want you to make sure you answer question 2 and 3 on the next page. That's going to hopefully tie a lot of this together. Use those graphs and those equations as references. And I'll give you kind of a hint here in a minute to maybe help you out if you're struggling. Okay, so for those of you struggling getting started a bit, try to relate the turning points to your degree. You can relate. Did anyone do that? Relate the turning points to the degree. It'll help you out a bit. Okay, so number of turning points. Notice, actually, it's a little easier if I use this page. Oops. Open the binder would help. All right. Notice this is a cubic. How many turning points? 2. This is a quartic. How many turning points? This is a quadratic. How many turning points?
1.
Cubic. How many turning points?
3.
Cubic. How many turning points? 2. Cubic. How many? Or fifth degree. How many turning points? 2. Uh-oh. So some of you had an idea, and then you're like, oh, man. Okay. How about here? How many turning points? 1. So what's it appear like if we ignore graph E? What's it appear? Good. The number of turning points is always 1 less than the degree. That's what it appears. Does it have to be 1 less than the degree? No. I mean, this one kind of disproves that. We only need 1 time. Okay? So if we add the words at most, that might help out. Okay? So the number of turning points is at most has the graph of a polynomial function of a degree n. So if we say our function is to the nth degree, okay, it has at most n minus 1 turning points. In other words, if you take the degree and subtract 1, that's the most turning points it could have. It can't have any more than that. Okay, and some of you will go back to linear. Like linear is first degree. How many turning points? None. It can't. It doesn't have any. Quadratic has 1. Okay? Cubic, well, most of you, when you first started looking at cubics, you just saw that. There's not any turning points right there. Okay, there's a slide, but you don't have any maximums or minimums. So really, here, there's no turning points on this one. However, we do know with a cubic that you could have up to 2 turning points. Okay, so this x cubed has 0, whereas this x cubed has 2. Okay, so it's always 1, or at most 1 less than the degree. All right, the next question. Is it possible to sketch a graph of a cubic? Oh, I just gave that away. Unbelievable. All right, well, there it is. The answer is yes. Don't confuse turning points with the slide. Turning points means you switch from increasing to decreasing. Okay, that's a turning point. You switch, your y goes from going up to starting to go down. The function is, rather than increasing, it's falling. Okay, questions? All right, let's try to graph some of these things. Actually, before we graph them, let's reference this. This is the next page of your student journal, page 113. This, for those of you that are using these to take notes, we're going to talk about even and odd functions tomorrow. We've referenced local maximum and minimum today. Okay, these things right here, remember, this means you have a polynomial. That's what that means. So when you just see that in a book, like next year when you're studying your pre-calc book, and you're like, oh my gosh, that just means you have a polynomial. I have a polynomial, and then we move on with life. Okay? K is a 0. So in other words, it's a 0 of our polynomial. And they're saying, well, if that's a 0, then we know x minus k is 0. Just like if I said, hey, you have a polynomial, and 2 is a solution. You would say, okay, well, then one of my factors is x minus 2. That's all that's saying. Okay? And then all right, and the solution k is a solution or the root of the polynomial if f of x equals 0. So in other words, it's a solution or root as long as we've set our polynomial function to 0. So rather than saying f of x equals, we now say 0 equals. That's all you're doing with that. The x-intercept, this is what we referenced the other day. If k is a real number, then k is an x-intercept. So remember, it can be a solution and be imaginary. It's an x-intercept if it's a real number. So in other words, it's going to cross the x-axis as long as it's a real number. Or another way to think about it, it's going to cross the x-axis as long as my solution does not have a, what? Imaginary number in it. Okay? So really what they've done here is kind of what we've talked about throughout the chapter. They're summarizing it for you. Now, for some of you, you're like, that's not the summary I like, because that's a lot of gibberish that I don't quite get. Okay? Start making notes to yourself about what that all means. I'll help you out. I'm going to give you a minute or two to kind of summarize that in your words. This is usually where you go back to look at your notes. Okay? Draw a picture if you need to down here. Okay? All right. So, here's what I want to do next. I want to do one graph with you and then get you guys going on your assignment here. All right? So, the one graph. Number 1 under monitoring progress here. If you wanted the learning goals and the page numbers of your book, it's up there as well. We're going to do graph number 1. You can just do this on your note page. This isn't in your book. Okay, so on the back of your note page, you have a grid you can use. Just want to explain exactly what I'm expecting when we go through these now. Okay? All right. So, as we go through these, first, I want us to identify what degree is it. Okay? So my degree is, remember this is a second degree, and this is a first, so 2 and 1 is 3. Okay? Third degree, or x cubed, if you want to think of it that way. All right? Which tells me my in behavior, okay, is down up. Okay, now it would switch if this was a negative out front, right? It would become up down. All right? The y-intercept, well, it's not as easy when it's in factored form. There's benefits to factored form, but it's not as easy to figure out the y-intercept. But really what you have to do is you have to think, well, constant. My y-intercept is going to be my constant by my constant. But remember, you have 2 negative 4s back here. Right? So it's actually, if you think of it in terms of y-intercept, you have 1/2, which is that. You have a 1, and you have a -4 and a -4. Those things are going to be multiplied together to give you a y-intercept of 8. That is my y-intercept. Does everyone understand how we got that? Okay, you just multiply your constant value. So 1/2, 1, and then there's 2 negative 4s. Okay? All right, we are now going to calculate our maximum. Well, how are we going to do that? Well, right now the only way you know is to use your calculator. So calculate your maximum and if there's a minimum. All right, well, there should be. Once you put it in your graphing calculator, you'll know for sure. Okay, so when you get it in there, you get this picture, right? Okay, now before we put this in, if we would have added one more thing, it would have been a little easier for us to tell if there were maximum and minimums. What's the one thing that I haven't put up here that we usually would have? Yeah, your x-intercept or your zeros. So that may even be like up here, probably after in behavior. We may want to list zeros. I mean, because that helps us determine whether or not we are going to have max and min. So our zeros, we have -1. That makes that part 0. We have +4. How many times? Twice. We have 4. We have 4 twice. Now that means we have a turn at 4. Those should be brackets. Okay. We have a turn at 4. So think of it this way. I mean, if we just did now we're supposed to actually graph it, but if I did a quick sketch here, I know I start down here, I jump up through -1, and then I've got to come back down and hit 4 and jump back up. That automatically tells me. Remember what we did the very first lesson? I said, hey, just do a quick sketch. Find your zeros, do your turns, you got it. That's what you're doing, just really quick. Okay, I've got a max and a min. That means I'm going to have a maximum and a minimum, just by doing that quick sketch. And then once you graph it, you can calculate your maximum and min. Remember, that's just second calc, and then minimum. And that's down here, so we've got our left bound, our right bound, and then our guess. Looks like 3.999, so in other words 4, and 1.61 e -12. Dude, that's a 0. All right, so minimum 4, nothing. How do we know that? Well, look, dude, it turns right there. It bounces there. Right? We should have already known that minimum. Okay, maximum. I get 2/3 or 0.66666667. We'll go like that. 0.67 and 9.26. Okay, the next step is to put all that stuff together. Okay, all this, use all those pieces to make a graph. Okay, plot your zeros. Okay, go through and put all those things together there. Okay, so notice I put my zeros, my y-intercept. I know my end behavior. I've got my max, 2/3, 9.26, so it's a little farther up there. I've got my min right here. So I start down here. So we want to start down below, cruise on up. Actually hit your points. Turn, come back down, turn again, and jump back up. Okay, so we're just adding our turning points now. So we're adding this and making that. Making it a little more accurate there. Looks like mine gets a little wavy here, but. Okay, and remember, you can always make. Hey, all you guys talking over me? Thank you. Okay, you can always make this even more accurate by calculating other points in between. All right, but right now all I expect 0, y-intercepts, and your turning points. Okay, any questions?